Okay, in 3.1 of IM2, we're going to discuss quadratic relations and functions. A quadratic function is a nonlinear function that can be written in the standard form that we've seen in Chapter 2, y equals ax squared plus bx plus c, where a does not equal 0. And of course, we know that a cannot equal 0 because if a equaled 0, there would be no x squared, and so it would be linear. Okay, the u-shaped graph of a quadratic function is called a parabola. Okay. In 3.1, you will graph quadratic functions where b and c are 0. So you're just going to have y equals ax squared. Okay, in your journal on page 76, this is all discussed for you. It's telling you that the lowest point on your graph is called the vertex, okay, or the highest point if it's shaped like this. And the vertical line that goes down through the vertex is called your axis of symmetry. And one really important thing that you need to remember about the axis of symmetry is when you're asked to give it, you always write it as a line. Okay, so if you just put 0, it would be wrong. It has to be written x equals then whatever number goes through your vertex. So the x of your vertex is your axis of symmetry. Okay? All right, notice that the graph of the y equals x squared represents a function also. Each domain value is paired with exactly one range value. It passes the vertical line test. A function represented by a quadratic equation is a quadratic function. So this graph, if you were going to describe it, is vertically aligned and it opens upwards. A graph that is vertically aligned but opens downward would look like that. The ones that are not functions are the horizontally aligned quadratics, but we aren't going to be talking about them in IM2, and they open to the left or the right. So, quadratic equations and their graphs. For any quadratic equation in two variables, every point on the graph is a solution to the equation. And because it has lines going like this, all the solutions appear, because we're telling you that it goes on and on forever. But remember, even though you can't see the entire graph, it doesn't stop. That's why we put the arrows. Some parabolas open upward and some open down. So what's the first difference you see between these two equations? Hopefully what you notice is that a is positive here and a is negative here. So when a quadratic function is written in the form y equals ax squared plus bx plus c, the value of a determines the direction of the parabola that the parabola opens. So a parabola opens upward when a is greater than 0, and I always called it the happy parabola, okay, because it looks like a smile, and it's positive. Positive people are happy people. A parabola opens downward when a is less than 0. So think of a frowny face is negative. Okay, when a is negative. Positive a, negative a. So if you're identifying the direction of a parabola, the first thing you want to do is find y. And then you move everything away for y. You're solving for y. So I'm going to add 1/4 x squared to both sides. And I get y equals 1/4 x squared plus x minus 3. And I can see that now I have it solving for y, and since the parabola a is greater than 0, the parabola opens upward. Okay, so now we're going to see if we can find out whether these graphs are opening upward or downward. So the first thing you want to remember is put it in the standard form, y equals negative 3x squared. The leading coefficient is the one that will tell you if it's upward or downward. So since a is less than 0, the parabola opens downward. For this one, I'm going to subtract 5x, add 5x to both sides. Always use opposite operations. I get y equals 5x squared plus 2x minus 6. And since a is greater than 0, the parabola opens upward. Okay, the minimum value of a function is the least possible y value for that function. the maximum value of a function is the greatest possible y value for that function. The highest or lowest point on a parabola is the vertex. Therefore, the highest or lowest point, the minimum or maximum, is in the vertex. So if I had a vertex of 4, 6, then this is a maximum and it equals 6. You don't have to put y equals because it's just a point. If my lowest point occurs at -2, -6, then my minimum is -6. Okay? So it's the y value of the vertex. So here's some graphs we're going to identify. So first thing I'm going to do, there's my vertex at 1, -3, and that is a minimum of -3. Okay, then I look at this one, and I can tell right away that it's a maximum. My vertex is 2, 4, so my maximum is 4. Okay, so I'm going to let you guys go ahead and do these, see how you do, and then I'll go over them with you. Okay, so the vertex here is 0, 0, and this is a minimum of 0. Okay, my vertex here is -3, -2. This is a minimum, and it is -2. Up here, my vertex is -2, 4, and this is a maximum. Think of a maximum as a height, is a mountain, minimum is a valley, and my maximum equals 4. It's always the y value. Unless a specific domain is given, the domain of a quadratic function is all real numbers. One way to find the range of a quadratic function is by looking at its graph. So I can see it goes on forever, and it's going to cover all the x's. So my domain is all real numbers. But my range has a limit because there are no y values below here. So to describe my range, I would look at my minimum value, where y equals 1, and then I have all the values that are greater than or equal to 1 appear somewhere on the graph. So the range is y is greater than or equal to 1. Okay, try this one. Okay, so my domain again is all real numbers, and I'm going to go like this. First thing I want to double check is, are these by 1? And they are, so this would be 1, 2, -3. And so the answer is, the vertex is -5, -3, so the maximum is -3. The domain is all real numbers, and the range is y is less than or equal to -3. Okay, find this one. First, what is your vertex? And so what is this a minimum or a maximum? And the answer to that one is that the vertex is -2, -4. And my minimum, because this is a low point, my minimum is -4. Now what's my domain? Looks like all real numbers to me. My range is y is greater than or equal to -4. So what you can see is if you have a maximum, y is going to be less than or equal to the number. And if you have a minimum, y is going to be greater than or equal to the number, the y in the vertex. Okay, so in the blue graph, a is positive. So the parabola opens upward. In the red graph, a is negative, so a is -1, so a is negative. The parabola opens downward. The graph is increasing or decreasing based on its movement from left to right. So we can see this is decreasing, this is increasing, this is increasing, this is decreasing. So it's really important that you understand that. Okay, the axis of symmetry divides the parabola into two symmetric parts. It passes through the vertex. It shares the x value with the vertex and is written as a line. Okay, so now we have our vertex is xy. X equals whatever is our axis of symmetry. And the y identifies our maximum or our minimum and helps us figure out our range. Okay? All right, so let's look at this graph and figure out all these questions about it. So first question, what is the domain? Hopefully you said all real numbers. I'm going to get a different color. Okay, so it's all real numbers. Okay, what is the range? So look here, my vertex, I'm going to quickly find that, is 3, -4. So my range is going to be y is greater than or equal to -4. When is it decreasing? So it's decreasing from infinity when x is greater than infinity or less than the lowest point, -3. We go by the x's, right? So it's decreasing until x is 3. So that is the decreasing part of my graph. Okay, and that is the way you could write it. It's never equal to the lowest point, and it's never equal to infinity. Okay? When is it increasing? I would say from x is greater than 3 and up till infinity. So you could put -infinity over here. That differentiates between the two infinities. Okay. What is this? That's the vertex. And we already found that, which was 3, -4. And what is this? That's the axis of symmetry. And the axis of symmetry is x equals 3. And since we've done this, we know that it's a minimum, and the minimum is -4 because it's the y of the vertex. Okay? All right. So identify the characteristics of the two quadratic functions on the bottom of page 77 in your journal. So you're going to identify all the different things about it. So push pause and see what you can find. Okay, so here's what I found, and I just drew them all on the graph. So my range is y is greater than 0. Here's my vertex, which is -1, 1. My axis of symmetry is -1. Notice it's the same as this. And my domain is all real numbers, decreasing part, increasing part. Okay, so now that I've done that one, you do number 2. Okay, so here's what we've got for this one. And the vertex is up here at 3, 4, which means my axis of symmetry is x equals 3, and my range, since it's a maximum, is y is less than or equal to 4. Okay, so there you go. All right, so how does the value of a affect the graph? What does this do? Well, we're going back to stretches and shrinks. And pretty much what you learned about those for linear lines follows the same. So if you look at this, when it's a whole number, the graph stretches up higher and it stretches away from the x-axis. Okay? So a whole number means a stretch because it's stretching away from the x-axis. Now, fraction, and when I say fraction, it has to be a fraction less than 1 and greater than 0. Okay, so it can't be 1.5 because that wouldn't work. So if you have a fraction, then it's shrinking. Think of this as shrinking away from, closer to the x-axis. So it's shrinking away from the basic function, which is this one here. Okay? So stretching away from the x-axis if this is a whole number, shrinking towards it if it's a fraction. And that would be the factor that you would write. Okay, so this is explained really well in your journal, so you could look there. Notice we have down here, kind of hidden, we have a negative, which means it's a reflection. Okay, we know that too. If we have a negative a, then that means we have a reflection over the x-axis. So everybody got that? Okay. So here it is explained. This is what it looks like in your book. It's not as colorful in your journal, but there it is for you to review in your book. Okay, so now we're going to look at these functions that are written in your book, in your journal, on page 78. And you're going to describe how the graph of each function would be different from the basic graph, okay, which would be x squared, which is 1. So first thing you notice is what's different. So for the first one, and you didn't have to graph these, but I just wanted you to look at them, the graph of g is a vertical stretch of the graph of f. You could say by a factor of 5. Okay, let's look at number 4. I have two things are different. How would you describe those two things? Okay, the graph of m is a vertical stretch with a reflection over the x-axis of the graph of f. Number 5, I can only see one thing. So the graph of k is a reflection in the x-axis of the graph of f. And I don't know why they don't say over, but that's what they're saying. In our old book it said about. So I guess different math people use different terms. They're probably Canadians, because Canadians say about a lot. So maybe it was. And this one, there's two things going on, so explain what they are in your mind, and then check. It's a vertical stretch, and it's also a reflection. Doesn't matter which order you put them in, but like we found on the other test, it's nice to put them in order. Everybody good? All right. All right, so we're going to talk quickly about graphing a quadratic function. We need to remember that a graph of a quadratic function is a nice smooth parabola. It does not look like that, so don't make your graph look like that. If you graphed on a test, you would lose 1 point for making it pointy. So make sure it's rounded at the top. To graph a quadratic function, you need to generate enough ordered pairs to see the shape of the parabola. I usually say 5, or at least 4 on one side. Then you're going to connect the points with a smooth curve. So, okay, a helpful hint when graphing is to choose positive, negative, and values of 0 especially. If your slope is a fraction, use numbers that will cancel the denominator. And here's an example of that. Okay, so here's an example of one of those ones where I would use different numbers rather than -2, -1, 0, 1, and 2, because I don't want to deal with the fraction. So I go 1/3 times -6 squared equals 1/3 times 36, and that's where I got my 12. So I'm going to factor all these numbers, but once I get over to my graph, I see that 12 is off the graph. So I'm going to just graph these 3 on the graph, and when I'm done, my graph should look nice and symmetrical. Okay? So notice that this is one of the points that we were given, and this is another point that we were given. They put in between points, but you actually wouldn't be able to exactly mark those on your graph. That's why I use numbers that cancel the fraction, because I want it to be accurate. Okay, so let's try this one. So we're going to put the t-table together, and I'm just going to use the regular numbers that we use most of the time, which are -2, -1, 0, 1, and 2. So -4, I'm just going to give you an example. -4 times -2 squared is -4 times 4 is -16. So then I'm just going to put all those values on there. Then this graph they made by 2's going down, and when you graph it, it looks like this. So again, these higher points, these higher numbers are not on the graph, but there are the 3 points that are in the middle. Okay, notice it's not pointy. Okay, so that's the end. That's a lot of information. So study it and think about it, and good luck with 3.1.